Hello viewers, welcome to the video lecture series on machine learning. Today's topic of discussion is on the introduction to decision tree and ID3 algorithm. So here in this session, I'll explain you what is a decision tree and why do we go for the decision tree algorithm. And also I'll show you the different steps in the ID3 algorithm, which is the most popular algorithm under the decision tree. Decision tree is a supervised machine learning algorithm used for classification and regression tasks. In this case, what exactly happens is whatever is the data set given. For example, here I'm showing one simple data set which is having the two features, assessment, assignment, and the target attribute is pass and fail. In this concept of decision tree, it splits the data into smaller subsets while at the same time an associated tree is incrementally developed. The end result is a tree with decision nodes and leaf nodes. So here, suppose if this is the data set here, now this data set is having what the student's performance attributes, assessment and assignment. So based on the assessment and assignment, the student is classified as pass and fail. Now which particular attribute is actually contributing, or we can say which feature are the most important features for making decisions. So here we have two features, not a big problem, but when we have a huge data set with multiple features, so out of those multiple features, we don't know which feature is the most important feature for making the decision. How to decide that feature? We can decide from the steps of the decision tree algorithm. Presently, I will not go into detail the steps. Here, I'll first tell you in the introductory part, out of these two features, assessment and assignment, now which feature is contributing towards the performance, whether it is pass or fail. So the one which is most important is brought on the top of the tree. So we are always using on the top of the tree this kind of symbol. This is called as the root node. So in this example, you can see that we have chosen assessment as the feature for the root node. Now this assessment has got the values greater than or equal to 50 and less than 50. So greater than or equal to 50, the student is categorized as pass, whereas less than 50, immediately we are not going to say that the student is going to fail if it is less than 50, but rather we'll check the next feature here, the assignment feature. So if the student has submitted the assignment, even though assessment is less than 50, the student is categorized as pass here. If the assessment is less than 50, assignment is also not submitted, then the student is categorized as fail. So basically, out of the given data set, you are going to select a feature which is going to contribute or which is the most important feature to make the decision. So this is just a simple example. You can easily decide. In this example, we have taken the assessment as the most important feature to take the decision. And also you should be knowing why we have chosen assessment and why not assignment. So in this algorithm, we have one parameter called as information gain. When we compute the information gain for all the attributes in the given data set, and when we check that whichever attribute is having the highest information gain, that attribute will be chosen as the root of the tree here. The first level here, since that is at the root node, we have the assessment, and in the next level we have the assignment. So now how to make use of these symbols in the decision tree? So based on this only we are going to construct the decision tree. As and when we contribute the information gain, we start placing the node on the top of the tree. Then in the next level, once again we split the data into subsets and choose the attribute which is most important in taking the decision, and that attribute will place it in the second level. So in the decision tree, now we are having this kind of nodes, this round on the circle shape, we are using it for the root node. The root node is this one here in this example, assessment. Root node is the top node where the first feature is checked to split the data. In this example, we have taken assessment as the root node. Decision nodes are what? Decision nodes are the internal nodes, and these nodes represent decisions based on the features value. So these are the decision node. We are making use of this kind of symbol here for the decision node. Then we have the leaf nodes. The leaf nodes are represented in this manner using this symbol. So for the leaf nodes are the nodes that give the final output. That means a class label or value. Leaf nodes are the terminal nodes that gives the final output. You can check here the leaf nodes. The final output is what? In our target attribute, it is pass or fail. So all the leaf node ends with this value only, output value, either pass or fail. And also we should be knowing one more term associated here. One is that is called as the splitting. Splitting is a process of dividing a node into two or more child nodes based on some condition. The tree has got two branches. One branch is moving towards this side, wherein you can see the assessment is greater than or equal to 50. The other branch is here less than 50, so which in turn may have the final leaf node, or it may have another feature node or the decision node in the tree. So as I said that we are going to compute the information gain. You will see in detail in my next session about this. Presently you can say that whatever is the data set given, we say the data set is having uncertainty or the data set is impure. So there are impurity measures. Based on that we can decide the splitting. Impurity measures are Gini index, entropy, mean squared error. This is for regression, mean squared error. I am taking into account entropy here. Entropy is a measure of uncertainty or impurity in the data set. So we want to split the data in a way that reduces the entropy. That is, it makes the groups more pure. Higher the entropy, higher is the uncertainty. Lower is the entropy, lower is the uncertainty. The attribute that gives the biggest drop in entropy is chosen to split the data. This is measured by information gain. So basically the entire algorithm, you are going to take into account the entropy and the information gain of the features that are there in the data set. If the entropy value you are computing for a feature is more, then there is more impurity in the data set, more uncertainty in the data set. Higher is the entropy, higher is the uncertainty. When we compute entropy for a feature, we will compute the information gain, and entropy and information gain are related. So if a particular attribute is having the highest information gain, it is having the lower entropy also. So we will take that attribute as the root node in the decision tree. The feature which is going to give the highest information gain or the lowest entropy is going to get selected as the root node in the decision tree. So the entire process we will see it with an example in the next session. Presently this session is about the introduction to the decision tree. So basically you should be knowing what is a decision tree and why do we go for the decision tree. Because we want to decide which features are the most important features for making decisions. We are not able to figure it out from the data set that is given because there is a lot of uncertainty in the data set. So we go for the decision tree algorithm and try to decide which features are most important for making the decisions. So in doing so, we have to make use of this tree construction. So this tree construction has got the root node, decision node and the leaf node. So when to use the root node and when to use the decision node and when to use the leaf node, I have explained just now. Entropy and information gain are the two important measures that we will be computing for every attribute that is given in the data set for the decision tree algorithm. But we have to make use of the algorithm, and this algorithm is called as the ID3 algorithm. This is one of the most popular algorithm in the decision tree. So in this algorithm, what we are going to do is, the very first step is we will compute the entropy for the whole training data set based on the target attribute. Presently you may not get the clear picture of what are these steps doing, but I'll explain the same thing with an example in the next session. Now just you see into the steps that are there here. First step is to compute entropy for the whole training data set. Second step is compute entropy information and information gain for each of the attribute in the training data set. Third step is choose the attribute for which entropy is minimum and therefore the gain is maximum. As I said, we are going to select a feature which is having maximum gain, and when we compute the gain, definitely that feature will have what? Minimum entropy, and that attribute is taken as the best split attribute. So on that attribute only you are going to split the data set. The best split attribute is placed as the root node. The root node is branched into subtrees with each subtree as an outcome of the test condition of the root node attribute. Accordingly, the training data set is also split into subset. So we are branching the tree based on the condition of the root node only. As we have seen in this example, if the assessment is less than 50, it is branched. Okay, if it is greater than or equal to 50, it is taking into another branch. So that is what we are doing here in this step. So when we branch, actually what we are doing is we are splitting that data set into subsets. Now recursively apply the same operation for the subset of the training set with the remaining attributes until a leaf node is derived or no more training instances are available in the subset. So you keep repeating this process until you reach to the leaf node, or you see if there are no instances remaining in the given data set. So these steps, whatever I have written here, the 6 steps will be more clearer to you when I teach you with an example in the next session. ID3 stands for iterative dichromatizer 3. So in summary, I can tell like this: ID3 is a decision tree algorithm which is developed in 1986. It is used for classification and regression problems. It builds a decision tree by selecting the feature that gives the highest information gain at each step. Hope you find this information useful. Please like, share and subscribe to my channel. Thank you. Bye bye and take care.